Good morning, class 12. You all know that we were discussing about the chapter electrochemistry. Very important chapter. In fact, most important, because from this chapter, one numerical and some questions, of course, they always comes in the exam. So you all are requested to just go through this chapter, just revise it thoroughly. Today we are going to discuss the second last topic, in fact the last topic, that is commercial batteries. We all know what is a battery. A battery is a source of electric energy. In a battery, chemical energy get converted into electric energy. We have seen batteries at our homes, inverter, they carry batteries, in our bikes, cars and lots of other things. We have seen the batteries. So there are two kinds of batteries or cells. One is called primary cell and second is known as secondary cells. What is the main difference between these two? Primary cells are those cells in which a redox reaction occurs only once. They can be used once and after that you cannot recharge them. They are called primary cell. We have example. We have Daniel cell. We have button cell. So these are the examples of primary cells. Whereas secondary cells are those which we can recharge over and again, in which the redox reaction can be reversed at any instant of time. Like mobile. In our mobile we are using lithium ion batteries which are rechargeable. We use the mobile, battery get finished and then after that we put it into the plug, we recharge it and then again we use it. So charging and discharging, both the processes takes place in secondary cells, whereas primary cells cannot be recharged. So now we are going to discuss about various cells. So batteries are classified into two categories. Primary, we call them primary cells, and second, we call secondary cells. Primary cells in which redox reaction occurs in one direction cannot be recharged over anything. For example, mercury cell, Daniel cell, etc. Whereas secondary cells, those cells in which redox reactions can be reversed. That means can be recharged over and again, like lead storage battery. Very important example. Lead storage cell or battery. Then lithium ion battery. Nowadays we are using mercury cell, that is lithium mercury cell. That is very effective. It has a long life. It can be used for longer period of time. So you can see here primary cells, they are generally use and throw. We use them and then after that we throw them. So the use and throw are primary cells, whereas secondary cells or secondary batteries are rechargeable. Now we are going to discuss about few cells, their reactions and their uses. So first we are going to discuss about dry cell. Now we are going to discuss about a very important cell which is called dry cell, which we normally use. Dry cell is normally used in watches, that wall clock. We have cells. Cells are used in torches also. Here you can see in a dry cell which contains a graphite. Graphite is carbon which acts as cathode. A rod of graphite is kept in a porous paper, and this porous paper, here you can see, this porous paper acts as a salt bin. It's just like a salt bin which has small porousness which allow the movement of ions. Now, this porous paper, inside the porous paper, we paste or we keep a paste of MnO, that is magnesium oxide, plus carbon. Keep in mind, when we talk about dry cell, we must keep in mind what is cathode and what is anode, what kind of paste are present and how it works. So, zinc rod is dipped in a solution of magnesium oxide plus carbon. It is just like jelly-like paste. Then outside the porous, in a zinc container, this is a zinc container which acts as anode. Inside the zinc container, we place a paste of ammonium chloride and zinc chloride. Ammonium chloride acts as electrolyte. So let us again see what happens. In a dry cell, rod of carbon, that is graphite, is kept in a paste of magnesium oxide and carbon. These three things are placed inside a porous paper. The whole apparatus is kept in zinc container. Zinc container acts as anode, and zinc container contains a paste of ammonium chloride and zinc chloride. Now, when we use this cell, when we use to the external wires, we connect to the external, we say that load. So when this cell works, the reactions which takes place at anode, since zinc container acts as anode, and we know left oxidation anode negative, means anode is always negative terminals, and at anode oxidation takes place. Here zinc loses 2 electrons, get converted to zinc ion. Now reactions at cathode. At cathode, the paste of magnesium dioxide, ammonium ions, they gain 2 electrons, get converted into Mn2O3 plus releases ammonia gas plus water. The overall reaction, when we write 2 electron got cancelled, the overall reaction will be 2 MnO2, that is paste of magnesium dioxide plus ammonium ion plus zinc get converted to Zn2 positive plus Mn2O3 plus 2 ammonia plus water. Now, one of the most important questions which comes in exam. Question is, the ammonia gas produced in dry cell does not come out. Why? Or what is the role of anhydrous zinc chloride used in dry cell? You can see here the ammonia gas produced here. It combined with zinc chloride, anhydrous zinc chloride. One, it absorbs the moisture, that is water. And second, zinc chloride react with ammonia to form a compound diamine dichloride of zinc 2. It forms a semi-liquid. That is the reason the ammonia gas produced in dry cell does not come out. It gets converted into a semi-fusible liquid. That is diamine dichloride of zinc. So keep in mind, when we talk about dry cell contains a carbon rod immersed in a paste of MnO and carbon. They are kept in a porous paper, and the whole container is made up of zinc. Inside the zinc, we have a paste of ammonium chloride and zinc chloride. Ammonium chloride acts as electrolyte. whereas anhydrous zinc chloride, it absorbs the moisture as well as the ammonia gas produced during the working of dry cell. These are the reactions which occurs at anode, and this is the reaction which occurs at cathode. So this is how a dry cell works. So here is a metal cap. Keep in mind, a metal cap is used so that it do not produce more resistance. So this is the first cell, dry cell. Now we are going to discuss a very important cell whose name is mercury cell. A mercury cell is a cell which gives a constant voltage throughout its life, and its constant voltage is 1.34 volt. Keep in mind, the question comes in exam, name the cell which gives a constant voltage throughout its life, and that cell is mercury cell. Why mercury cell always gives a constant voltage of 1.35 throughout its life? Because when we see the overall reaction in the mercury cell, zinc solid plus mercuric oxide solid get converted to zinc oxide solid plus mercury liquid. Since the overall reaction does not contain any concentration term, it means it gives a constant voltage as its concentration does not change. So sometime, of course, after some time, the mercury cell, it stops working. Why it stops working? Because of corrosion of zinc anode. The zinc container in which the apparatus, in which the reaction takes place, it gets corroded. Hence, the cell gets leaked and cell stops working. So let us see what are cathode, what are anode, and what are the reactions that takes place in mercury cell. In a mercury cell, we contain a carbon cathode. Keep in mind, in mercury cell, cathode is carbon. The carbon rod, that is graphite rod, it is placed inside a zinc container having porous paper which acts as a separator. Means this porous paper, it separates the zinc container from ammonium, this paste, that is mercuric oxide and KOH paste. Keep in mind, zinc container, it acts as anode, and carbon rod or graphite rod, it acts as cathode. This cathode is placed in a paste of mercuric oxide and aqueous KOH, potassium hydroxide paste. So when the reaction takes place, of course, zinc, it gets oxidized, and here mercury, it gets reduced. So this is the diagram for the mercury cell, and here you can see the reaction at anode. Since zinc gets oxidized, zinc react with two hydroxide ions which we get from KOH, because KOH is a strong alkali. It dissociates to form ions. Zinc combined with two OH negative ions give its electron to OH negative ions to form water, form zinc oxide, and it releases two electrons. These two electrons, they move to the solution. When they reach the solution, mercuric oxide in the presence of water gain two electrons, get converted to mercury and release hydroxide ions. These hydroxide ions again gained by zinc to form zinc oxide, and the reaction continues. The overall reaction, two electrons, they get cancelled. The reaction is zinc plus this 2H also got cancelled. So zinc plus mercuric oxide gives zinc oxide plus mercury. Here zinc solid, mercury oxide solid, zinc oxide solid, and mercury is liquid. It always gives a constant voltage of 1.35 throughout its life, because the final reaction or the overall reaction does not contain any concentration term. So its voltage or its concentration does not change. Hence, voltage remains constant. So you have seen that today we have discussed about batteries. There are two types of batteries, primary and secondary. Primary non-rechargeable, secondary rechargeable. After that we have done a primary cells. We have done dry cell as well as we have done mercury cell. We have seen the reaction taking place in dry cell. Dry cell always gives a voltage of around 1.15 to 1.25 throughout its life, whereas mercury cell gives a constant voltage of 1.35 its whole life. So this is all for the day. Tomorrow we will discuss about few more cells. We will discuss about secondary cells as well as corrosion, that is rusting of iron is an electrochemical process. So you all are requested to just revise this chapter. Thank you.